G'day everyone, back here doing some more questions now. Thanks very much Alan Sadler. Methods 3, Chapter 3C, which is rectilinear motion. I'm going to do a couple of questions here out of that exercise. Question number 10 and then question number 14. Both really good questions for you to know how to do. Now question 10 is really packed in the language, so I'm going to read it and get the information up there. Try and follow along as I go. If you've got it in front of you, that's going to be handy as well. So it says a body initially at origin O. Initially at origin O. So I'm going to start with x equals 0, because x is my displacement formula. And if it's at the origin, then x has got to be equal to 0. Now because it says initially at the origin, that means x equals 0 and t also equals 0. So that's just in the first five words, we've got two pieces of information. And at that instant, that's meaning at time equals 0, the body has a velocity of 14 meters per second. So that means that v equals 14 when t equals 0 as well. Okay, so when time is equal to 0, we're at the origin with a velocity of 14 meters per second. I probably should add in the meters per second here. There we go. Then it says the acceleration t seconds later. The acceleration t seconds later. That's really just giving us a formula of acceleration in terms of time. It says is 3t minus 11. So acceleration is equal to 3t minus 11 meters per second to the minus 2. Find the velocity of the body when it is next at the origin. Well, next is an important word in there because it's already at the origin. We wanted to find when it is next at the origin. All that information came from that question. Only 2 lines in the question. Everything we need is here. Because we've got acceleration, we've got to remember that acceleration is the second derivative of displacement. We've got displacement, x in terms of t. We've got velocity, which is dx dt, or the rate of change of displacement with respect to time. And then we've got d squared x, dt squared, which is the second derivative of displacement, which is the rate of change of velocity. Hopefully that makes sense. Let me sketch a little diagram here. So we've got x of t here, we've got v of t here, and we've got a of t here. Now if we're coming this way, then we're taking the integral, okay? Oh, sorry, we're taking the derivative, right? But if we're going this way, then we're doing the integral of it, okay? So going down, we're taking the derivative. Going up, we're taking the integral. Now this is the key thing. Remember that when we take the derivative of something, we're losing a little bit of information off the end. So if I had y equals x squared plus 5, and I take the derivative of that, I get 2x. Notice how this part dropped out? So therefore, if I was to integrate that, I only get y equals x squared plus c. I don't actually know what that number is. Then, from other information, I'll be able to figure out what c is and get back to the original. So this is the format, this is what we're doing, but we've got to recognise that when we integrate something, there's an extra bit that we've got to figure out, okay? So let's see where we go with this one. Right, so I've got the acceleration, so I'm here. If I want to move to velocity, I've got to integrate. So I'm going to integrate acceleration dt. So if I integrate the acceleration, then I'm going to get the velocity, which will equal the velocity of t. Now to integrate the acceleration, I've got to integrate this thing. So I'm going to take that and put it in there. Alright, I'm going to write this one the other way around, make it easier for me. V of t equals the integration of 3t minus 11 dt. And that means I'll be able to come up with 3t squared over 2 minus 11t plus c. Okay? Being an indefinite integral, there's no limits, I need the plus c. So I've got a formula for velocity. Now what I need to do is look back in here, and this piece of information here is the one that I want. That's the bit of information, because that links velocity and time. Here I've got velocity and time, and that'll figure my c out. Now because when time equals 0, the velocity is that, well, when I put v of 0 in, okay, v of 0, which that part is equal to 14, this is going to equal 3 lots of 0 squared over 2 minus 11 lots of 0 plus c. So hopefully you see that that cancels out. So whatever the velocity at time 0, well, that's just equal to c. So therefore, let me write it in a full format. V of t equals 3t squared over 2 minus 11t plus 14. So now I'm here. I'm here. Doesn't help me to answer the question, because the question said, where is it? We'll find the velocity when the body is next at the origin. This will find me the velocity, but I don't know when it is next at the origin. When is t? So I need to now do this step. I need to integrate this again, the velocity of t again, and then I'm going to use this as the piece of information I need. So if I'm going to end up with displacement, if I want x of t, then I've got to integrate v of t dt. Okay, so that statement there is really the same as this one, just that I'm moving to the next step. So that means that this guy here is going to go in there, and that will mean that then I can integrate that. Let's see how we go. So x of t equals, integrating this one, raise the power by 1, it's going to be 3t cubed over, now it'll be 2 times 3 on the bottom line, minus 11t squared over 2, plus 14t, plus, now I could use c again, I'm going to use d, just so I don't get confused. It doesn't really matter, c, d, f, g, whatever you like. Now that there, I can see that I'm going to be able to cancel that 3 and that 3, so that's a bit neater. Now what I'm going to do is I'm going to use this part right here. Because when x is equal to 0, t is equal to 0. So if I put that in, that means that this is going to be equal to 0. So it'll be 0 equals, this part is actually going to drop out to 0, because when t equals 0, that whole thing disappears. This is going to be the same, this is going to be the same, and d is the only thing I've got left. Well, this is easy. D is equal to 0. And that makes sense, because it's at the origin when time starts. So graphically, that means that it has to be there when time starts. Now, time is this one, right? And there's an important part here about time, because this doesn't exist. This would be when time is negative. This is t is less than 0. Well, when we're doing these practical situations, any value where t is less than 0 has no meaning. That was before you started the experiment or before you started measuring. No meaning. Ignore it. If you get a question and this comes up, as in you need to, you work something out and there is a negative time answer. Say for instance you end up with t equals negative 3. Okay? It would be negative 3 seconds. I would then write a little statement saying discard t equals minus 3 as t must be greater than or equal to 0. Okay, you're discarding it, but you're giving a reason. All right, so what we need to find now is that, we can get rid of this. What we need to find now is the complete equation, or rather the times at which it's at the origin. Let's write this equation with this piece of information, which is really just getting rid of that. But if I go x of t equals, so this cancelled out would be t cubed over 2 minus 11t squared over 2 plus 14t. Now, What I need to do is find when this equals 0, because when that equals 0 will mean I'm at the origin. I already know I'm at the origin at t equals 0, but I need to find the next time. Now, I can factorise this. Look at this. If I take a t over 2 out, you're thinking, hang on, there's no t over 2 there. Well, there is. Write this one as 28t over 2. There you go. You can see the t over 2 there now. So, this is going to be t over 2 brackets. What are we going to be left with here? We're going to be left with t squared minus the 2 and the t is gone, so it'll be 11t, and we'll be left with the 28 there. Now, for those ahead, you can already say, well, 28, that's 7 times 4. If I make both of those negative, I'll get my minus 11t. So this is going to be equal to t over 2, t minus 4, t minus 7. Right. Now that we've got that, I can then say, therefore, when this equals 0, t is going to equal 0, that's this one here, or t equals 4, or t equals 7. Now, I already knew that one, because that's right here. The question told me that. But this is the next one that I want. This is the one that I want. Okay? That's the next time that the particle is at the origin. So, that one, let's grab that guy. Now, where do we need to put it into? Well, we need to put it into here. Because the question said find the velocity at the next time it's at the origin. So that's the next time it's at the origin. We take that, we put it into here and we work it out. Let's find ourselves some space. Let's get rid of this guy. Okay, so we're over here now. We're over here we go. Right, this guy. So I would need to work out V of 4 equals 3 times 4 squared. 4 squared is 16. 16 divided by 2 is going to be 8. Times 3 is 24. 4 times 11 is going to be minus 44 and plus 14. So what have we got? We've got 38 minus 44, which is minus 6 meters per second. So that would mean that the next time that it's at the origin, did I get that right? Yes, I think I did. The next time it's at the origin, it's actually travelling backwards. So I've got rid of the diagram here, but next time it's at the origin, it's actually going from the positive side across 0 to the negative side. Okay, that's what it's telling me about that. Hope this question's helped. This is question number 10, as I said. I'm going to keep going. Now look, that's question 10. Rewind it if you need to. Lots of good stuff in there. Question 14 now. Have a read if you've got it there. Question 14. It's a great question. Now I'm going to do about 2/3 of it, and then I'm going to leave you with the last part, because the last part is possible to do by hand, but I'd just jump on my calculator and do it that way, the last part. When you get to there, all of it's done. So, question 14 says, a particle travels along a straight line, rectilinear motion, such that the acceleration at time t, that's just the formula for acceleration, is equal to 6t plus 1. So all we know is the acceleration is equal to 6t plus 1. That's all we know at this point. Then it says, when t equals 2, the displacement is 12. And when t equals 3, the displacement is 34. So when t equals 2, x is equal to 12. When t equals 3, x was equal to 34, I think, yes, 34. Now, remembering that diagram I had here before, x, v, and a, right? This one here. Rewind if you need to see it again. Now, all of this information fits here. All of this information fits here. Now, if we're going this way, we're integrating. Now, remember that I said when we're integrating, we need some information to write from here, this one, completely. Otherwise, we've got a plus c hanging on there. But I've got no information about the velocity. And this is where this question is different. Because I need to integrate this to get here. I need to integrate this one again and get here. But there's a little bit of a trick in there so that I can use all this. Let's do the first part. Let's go that v of t equals the integration of acceleration of t dt, which would equal the integral of this, which is going to be 6t squared over 2 plus t plus c. Now, that's okay, and we're fine there. But what we've got to recognise is we're not going to be able to figure this out because I don't have any information about velocity. So now what I've got to do is say that x of t is equal to the integral of v of t dt. Now, this is v of t here, so I've got to integrate that. So, integrating this would get me 6t cubed over, bottom line is now going to be 6, plus t squared over 2, plus, now this is the trick, ct plus d. Remember, that is just a number. So if I'm integrating it, I throw t on the end. Now, I couldn't put, this would be wrong. Now, I don't know what these numbers are. They might be the same, but they might be different. And chances are they're going to be different, so I'm going to put plus d there. Now that's, you might go, well, yeah, okay, but where am I going with this? Well, now all of this is the key part. Let's substitute in the first one here. So x equals 12, so I could write 12 equals, putting the 2 in for t. Well, this is going to cancel, that's neat. So 2 cubed is going to be 8. This is 2 squared divided by 2, so that's just going to be 2 plus 2c plus d. Alright, leave that for a moment. Let's work on this one. X is equal to 34 equals, now putting 3 in. 3 cubed is 27 plus squared is 9 over 2, 3c plus d. Now you look at that and you think, what am I doing with this? Well, now I have 2 unknowns and 2 equations. So couldn't I just do this? Subtract one away from the other? Well, I could. 12 take away 34 is minus 22. Now, this I'm going to tidy up as being 10, and this I'll tidy up. This is 4.5, so this is 31.5. So 10 minus 31.5 is going to be equal to minus 21.5. 2c minus 3c is minus c. D minus d is gone. So now looking at this, well, I can get rid of all the negatives, so let's just make these all positive. And look at this, c must be equal to a half to make that work. The other way, move the 21.5 over, but c must be equal to a half. Now what I could then do, I'll leave you with this one, is then I could take that, put it back into either one of these equations, right, and solve for d. Therefore, d is going to equal whatever it is. And then let's check we've answered the question. Find the displacement when the velocity find the displacement and the velocity when t equals 4. So once you've figured these out and you can write your complete displacement formula, you could put 4 in and get the displacement, and you could also put 4 into here with c in there to get the velocity. Lots in this question and in the last one. Honestly, any one of those questions you could lift straight out the book, put in the exam, and put about 6 marks to it. If you know what you're doing, it would be 6 easy marks. These are the sort of questions that really test all your knowledge here, all your knowledge around this, simultaneous equations, substitution, integration, everything's in there. These are the questions I'd be practicing for my exam. See you later, guys. Enjoy.